This is basically a frequency distribution. Frequency distribution basically tells you how many times things are present. Okay, so many cameras display real-time histograms of the scene. Helps to avoid taking overexposed pictures. Overexposed pictures, and then you can easily modify by modifying the histogram, right? So histogram modification, we're going to probably talk about it. For example, a picture has this kind of a histogram. You can modify this to be a kind of a histogram, which is stretched something like this. Making certain pixels to change its pixel values so that they occupies the higher range values, so that the pixels is uniformly distributed across its range. So range is 0 to 255. If it is either peaking at one area, or it is not distributed smoothly, then it is going to have certain distorted versions. So these are histograms, so H of I. So this is the ith intensity that we have taken. How many times is the ith intensity present shown here? So there are 9 times it is present. So there's a value 9 is present 9 times. For example, value 2 is present in a pixel. Then you follow the. So it only tells you how many times present, but does not tell you the location of that particular pixel being present. So that is essentially a kind of disadvantage. If somebody says present at a position, that's it is also fine. But however, this itself is going to give you a lot of newer information. Sometimes images can have the same histogram, but they are different nature. For example, all 3 images gives the same histogram. If you can draw this, for example, between the values that are there, okay, so same statistics, but however they are different. So therefore it is always said that you cannot reconstruct the image from the histogram, right? So if the same histogram is representing these images, which one will you do? So there should be one-to-one correspondence between, for example, histograms. Okay, so H of I tells you how many pixels are there for a particular value. So this is I of u comma v, taking a I intensity value I is basically H of I, so number of values. So that's how histogram is basically mentioned. So when you want to interpret these histograms, okay, basically the contrast range is so much, but however the image is only occupying certain portion of this image, right? So when you look at it, this is in a typical logarithmic scale, you will get an image like this. A linear scale image is like this. So one has to use what is called as the linearity of this range in this histograms. Okay, so histograms help detect image acquisition issues, whether it is overexposed or underexposed, whether it's a high brightness or high contrast or low contrast. Okay, so sometimes what we are going to do is there is something called point processing or point operations, which can be used to alter the histograms. So alter the histograms. So either you can do some addition, or taking multiplication, or taking logarithm. So some of these things will help you to probably modify the image defects, right? So image defects can be many. So for example, the brightness of a grayscale image is defined as brightness value of this is the total divided by total number of pixels. For example, W is the width and height of the image. For example, number of pixels, W, and H, so the total number of image. So you're trying to average the you're adding all the intensities across one direction, and also adding other direction, right? So you go from left to right, top to bottom. So essentially this is left to right and top to bottom. So you get I of u. You add all pixels in the image and divide this image. What you do is you get an average intensity of this is a good example to do a small image processing applications, where, for example, this tells you what is the average value of an image, for example, image block, for example. So you can try to use that as a kind of your feature to probably detect something, right? For example,